Okay. All right, guys. Many of you have been telling me that you don't understand what we're actually doing, right? So, the problem was what is the what is the law of sines and what is the law of cosine, right? And when do we use them, right? So let's go ahead and talk about it. So now, before I actually talk about it, I'm going to just give you the simple definition of a triangle, right? So because all of these are just triangle. So we know that every triangle has we know three sides. They also call side length and three vertices, right? And we usually call these vertices angles. They also call angles. All right. So and we know that if you add the three angles, you should have 180 degree. The sum of the angle of a triangle is 180 degree. Right. So I'm going to go ahead and draw it. So a triangle look like this. So we have an angle A here, or a vertex A, vertex B, and vertex C. And we have a side A, side B, and side C. The way I drew it, so that it's very easy to write the formula as we go, right? So once again, here we have the angle or the vertex A, B, and C. I'm going to change the color for the sides. We have ABC, as you can see here. Now, we also know that we have a triangle that are called right triangle because they have a 90 degree included, and when there's no 90 degree angle included, we're going to call it oblique triangle, right? So we have what we call a right triangle. Okay, a right triangle will look like this one here. So you have, I'm going to do my best here. Okay, but let me use the ruler here. Let me use the ruler to kind of make it fancy. Let me go ahead and raise this and use the ruler. We have, this is exactly 90 degree, see? And we turn it. And this could be any angle here. The only important thing is that we have a 90 degree here. So we have 90 degree here. So this is called a right triangle. And to actually measure the side and the angle of the triangle, we use SOHCAHTOA. We spend time talking about SOHCAHTOA. Okay, everybody here should know what SOHCAHTOA is. So we use SOHCAHTOA to find the angles and the side. Okay, now I'm not going to focus on this type of triangle. I'm going to focus on triangles that do not have a right triangle that does not have this. So these are called oblique. So when we have an oblique triangle, we use the law of sine or the law of cosine to find the missing angles and the missing sides. Okay, so we do that only when we have oblique triangle. So we use the law of cosine and we use the law of sine to find the missing angle and the missing side. So that's exactly what we working on when we're talking about law of sine or law of cosine. Now, many of you may ask, When do we use the law of sines? When is it used? We use the law of sine when use this law when we are given an angle, side at an angle. How does it look like? Okay, let me say, let's say we have a triangle. I'm just going to take draw an oblique triangle, right? Okay, this is oblique triangle. You notice there's no right angle on this. So if you are given, see, if you are given the side, the angle, sorry, the angle, a side, and an angle. Okay, if this is given, if this information is given, this information is given, and this information is given, we use the law of sines. We also use the law of sine when we are given a side, and angle, side angle. Okay, so we use, say side. So if you're given side angle, so side angle, side angle. Okay, we use the law of sine. And another time we use the law of sine is when you are given an angle sides, right? Angle side will look like this. Okay, we have angle here, angle, and side. So basically, if you are given an angle here, and a side, that's when we use the law of sine. Okay, so once again, remember, we use the law of sine to measure the missing angle and the missing sides. For example, on this one here, if I were given this, what I will be looking for is, I'll be looking for this side here, this angle here, and this side here. On this one here, because these two are given, and this angle is given, I'm going to be looking at this angle. For this angle, I'm going to be looking for this angle, and I'm going to be looking for this side. For this one here, I'll be looking for the side, this side, and this angle. That's what I'm going to be measuring using the law of sine. So now, what is the formula? What does the formula look like? For law of sine, let me go ahead and write again our triangle here. Let's say I have side A, side B, side C here. Okay, I want to always make sure that my angle are opposite to the side. And then I have angle B and angle C here. All right, I'm going to kind of color code it so you can actually see what's going on here. So the law of sine says, law of sine, all right, so what I'm going to do, I'm going to have these two together, right? And I'm going to have these two together. And I'm going to have these two together. Okay, the angle and its opposite side. So basically, the law of sine is sine of the angle A, for example, over the opposite side is equal to sine of the angle B over the opposite side, and is equal to sine of angle C over the opposite side. So this is the formula for the law of sine that you got to use. Now, many of you are still confused with this formula because you think you have to use the three of them at once. No, you don't. Okay, just make sure whenever you are given a side, an angle side, all you have to do is to use the formula, plugging in what you are given to find what you are not given, what you're looking for. That's what it is. Let me go ahead and give you an example here, right? So once again, these are the three ways to use the law of sine. So let's do an example here. Example. Let's find, let's say we are given this triangle here. Okay, it's not drawn to scale, by the way. Okay, I have the angle A here, let's say it's 43.2. the uh, the angle C is 111. Okay, let's say you have this triangle here. Say this is 43.2. Angle C is 111.6. And the side A is 79.4. And they're asking us to find, let's call this angle B here, and this side C here, right? And this side B. So you kind of understand that this is going to be the angle C, and then this is going to be the angle A, right? So the question is find angle B, side B and C. All right. So before I start, let's say I did not know what I was doing, what law I'm using here. So all I have to do here is to pay attention to what I'm giving. I'm giving this one, this one, this one. So I'm giving a side angle and angle, side angle and angle. So I'm giving, for now in my head, I know I have side angle, angle. Okay. So if I look on my chart here, side angle, angle, right? Side angle, angle. Okay. Or it could be angle, angle, side, depending where I'm starting, right? Angle, angle, side. So I know, because I'm giving this, I'm going to use the law of sine. Let's look at what I have here. So all I have to do, I'm going to write down, this is my formula here. This is my formula. I'm going to plug into my formula what I have. So sine, so I know sine of A, so 43.2 over 79.4 is equal to sine of 111.6 over the side C. Okay. Now, from the get-go, I could actually find the angle B, right? The angle B as well. I can find the angle B. I know that the angle B is just 180 minus this 2 here. So the angle B is equal to 180 minus 43.2 minus 111.6, and that gave me the angle B it gives me 43.2. So I found angle B already. This is done, right? Now we need to really make sure that this formula here, it could be also, the reciprocal is correct as well. You just have to be very, very consistent, right? You could also write as A over sine of A is equal to B over sine of B is equal to C over sine of C. Okay, both work. You just have to be very consistent in what you're doing here. Okay, now that we have that, let's go ahead and continue with what we're doing here. Oh, by the way, it's not, I'm just this is not correct here. If I take my calculator, I do 180 minus all of that, I get B is equal to 25.176. Okay, that's my B. No, 43.2 is just 43.2. Okay, it gives me 25.17 degree. Now, let's continue. Matter of fact, you know what I'm going to do? I'm going to use this formula to the second formula, this one here, to find the other values. Right. So now I've written this down here, and that will give me C. I want to do it two different ways so you can actually see. C sine of 43.2 is equal to 79.4 sine of 111.6 So C is equal to 79.4 sine 111.6 divided by sine of 43.2. If you enter all of this in your calculator, you will have C is equal to 107.8. Okay, that's what you will have for the side C. Now, let's go ahead and calculate B. B. So we know B. I'm going to go back here, right? Back here. So B, sine over B is equal to sine B. So sine B over B is equal to sine A over A. All right. So I'm looking for B here. So sine B. I know B is 25.17. Sine 25.17 over B is equal to sine A. Sine A is 43. Sine of 43.2 divided by A. A is 79.4. 79.4. So now I have B is equal to 79.4 times sine of 25.17 divided by sine of 43.2. So B will be 49.341. Okay, so basically I'm looking for my missing number. So I have C here and then I have B. So I found the angle B, the side C, and then the side B. That's how you use the sine law, the law of sine, right? So this is all the work here. So you can go back from the beginning and find out what we have been doing here. So once again, this was the law of sine. So what we're going to do next we're going to use the law of cosine. So I'm going to do a different lesson so it's not too long. All right, on this one, take care and see you later.